Good, good afternoon to all of you. Myself, Professor N.V. Arpe from SND College of Engineering and Research Center. Now, in previous lecture, we have already studied the uh, classification of resistors and measurement techniques for measurement of low resistors, medium resistors, and high resistors. Now, today onward, we are discussing the AC bridges. Discussing the AC bridges. In that, we have uh, measure the value of inductance and capacitance by using various bridges. The uh, the content of that unit is course outcomes, sources and detectors of AC bridges, Maxwell inductance bridge, Maxwell inductance capacitance bridge, and Anderson bridge. The course outcome in that the course outcomes of that subject that is course of our course, that is electrical measurement and instrumentation. In that the classify second outcome is classify resistance, apply measurement techniques for measurement of inductance and resistance. Now we have the first topic, that is sources and detectors for AC bridges. Now we have already studied the Wheatstone bridge. In that Wheatstone bridge, there are four arms. Each arm consists of resistance, and there is a one detector. There is a one detector which is used for checking the bridge balance condition, bridge balance condition, and the sources which is used to give the supply to the bridge. In AC bridges, there are source that is single phase 230-volt AC supply, which is used for the sources for the high frequency source. We use the electronic oscilloscope. We use the electronic oscillators. I use as a source. And in a detector, there are three detectors which is used for AC bridges. First one is headphone, second tunable amplifier circuit, and third one is vibration galvanometer. The headphone which is used for the use as a detector for the frequency range of 250 Hz to 3 to 4 kilohertz. For vibration galvanometer which is used for low frequency, that is 5 to 200 Hz. The tunable amplifier used as a detector for the range of frequency from 10 Hz to 100 Hz. The general equation for bridge at the balance condition, for the balance condition. This is a bridge this is a AC bridge. There are four arms, that is arm AB, arm BC, BCD, and AD. There are four arms. Each arm consists of having impedances Z1, Z3, Z2, Z4, and the source is connected in between the points A and C, and the detector is connected in between the point B and D. The detector shows the bridge balance condition. When the detector shows the zero reading, that means the bridge is balanced. And if the detector shows any reading, positive or negative reading, then we can say that their bridge is not balanced. Then at that time, we adjust the any one impedance for the for making the bridge balance condition. For bridge balance condition, the main object is the potential at B and the potential at point D are equal. Means the difference between potential at point B and potential at point D should be zero. Means means uh, means the potential E1 is equal to E2. E1 is equal to E2 and E3 is equal to E4. When the source is connected to the bridge, then then due to this voltage source, the current will be flowing to the bridge. The current will be flowing to the bridge. Due to that, the current I1, I2, I3, and I4, which will be flowing to the corresponding impedances like that is Z1, Z2, Z3 and Z2. Means E1 is equal to E2, E3 is equal to E4. Means at E1 is equal to then I1 into Z1 and E2 is equal to I2 into Z2. And at according to the base balance condition, the current I1 will be flowing, same current will be flowing to the Z3. Therefore, I1 is equal to I3 is equal to E upon Z1 plus Z3. E upon Z1 plus Z3 and I2 is equal to I4 is equal to E2 the total supply E is equal to E2 plus E4 and E is equal to E1 plus E3 also. Then the I2 is equal to total E upon Z2 plus Z4. Put the value of I1 and I2 in that equation. Then by solving this equation, Z1 into Z4 is equal to Z2 into Z2. This is the bridge balance condition. This is the general equation of our AC bridges at bridge balance condition. That is Z1, Z4 is equal to Z2, Z3. But when we using admittances instead of impedances, then we can write the Y1, Y4 is equal to Y2, Y3. This is the general equation, but when we use the impedances or admittance in a polar form, then we can write the Z in terms of Z is equal to Z at an angle theta. Z at an angle theta, where Z represents the magnitude and the theta represents the phase angle of the complex impedance. Then the equation 1 becomes, then the general equation becomes Z1 at an angle theta 1 into Z4 at an angle theta 4 is equal to Z2 at an angle theta 2 into Z3 at an angle theta 3. Thus, for balance, we must have Z1, Z4 at an angle phi 1, theta 1 plus theta 4 is equal to Z2, Z3 at an angle theta 2 plus theta 3. This is a general equation of AC bridges at bridge balance. The next topic is Maxwell's bridge. The Maxwell bridge, which is used for the measurement of self-inductance of the circuit. This bridge is called as Maxwell bridge. It is the advance from the Wheatstone bridge. The Maxwell bridge works on the principle of the comparison, that is, the value of unknown inductance is determined by comparing it with the known value or standard value. The types of Maxwell bridge. There are two types of Maxwell bridge. First one is Maxwell inductance bridge and second one is Maxwell inductance capacitance bridge. First one, Maxwell inductance bridge. In such a type of bridges, the value of unknown resistance, the value of unknown inductance is determined by comparing by it with the known value of standard self-inductance. Means the unknown inductance which will be compared with the standard inductance. This is the circuit diagram of Maxwell inductance bridge. Maxwell's inductance bridge. In that, there are also four arms. The source is connected between the point A and C, and the detector is connected between the another 2 points, that is B and D. In arm 1, the resistance, the one coil is placed having resistance R1 and inductance L1. In second arm, R2, known variable resistance R2 and variable inductance L2, having internal resistance R2 is connected in R2 In R3, the resistance R3 is connected, and in R4, the R4 resistance is connected. Then by using the bridge balance condition equation, Z1 Z4 is equal to Z2 Z3. Then put all the values of Z1 Z2 Z3 Z4 in that equation, and by solving this equation or by comparing the real and imaginary term, we can find out the unknown value of resistance R1 and L1. The impedance of Z1 is equal to R1 plus J omega L1. Impedance of Z2 is equal to R2 plus J omega L2 plus R2. Z3 is equal to R3 and Z4 is equal to R2. Then Z1 into Z4 is equal to Z2 into Z3. By solving all the equations, R1 is equal to R3 upon R4 into R2 plus R2, small r2. This is R2 having the internal resistance of coil L2. L1 is equal to R3 divided by R4 into L2. R3 upon R4 into L2. This is your Maxwell inductance which is used for the measurement of inductance, unknown value of inductance with the comparison of known value of inductance, that is L2. The value of R3 and the R4 resistance varies from 10 to 100, 1000 ohm with the help of resistance box. Sometimes for balancing the bridge, the additional resistance is also inserted into the circuit. The phasor diagram of Maxwell inductance bridge is shown in that figure. The I1 and I2 are taken as a reference. Then I1 R1 resistors are in series with the voltage of resistors are in phase with the current. The voltage of inductance, that is J omega I1 into J omega L1. This will be in a 90 degree leading with the I1. Then the addition of both, that is E1 is equal to E2. I1 omega L1 is equal to I2 omega L2. This one. Then I1 R3 is equal to I2 R4 is also taken in phase with the current I1 and I2. The addition of E1 and E3. The addition of E1 and E3 is nothing but your total inductance. Total EMI. Addition of E1 plus E3 is equal to total E. Then by taking the phasor addition and find the total EMF, that is total voltage of circuit bridge, that is this is your phasor diagram of Maxwell inductance bridge. The Maxwell inductance bridge is used for the measurement of unknown inductance with the help of with the comparison with the standard known inductance. So in the next lecture we will discuss the next two topics, that is Maxwell inductance capacitance bridge and Anderson bridge. This is also used for the measurement of inductance. So thank you.